In this tutorial, we discuss creating and designing adaptive elements in your games. We then explain how this adaptive game design methodology is implemented in Orbit. Firstly, we must explain what we mean by adaptive elements. An adaptive element is a game mechanic, AI agent, or group of AI agents that change behavior based on input. A simple example would be difficulty settings in a game. The difficulty settings, easy, medium, or hard, form a discrete set of inputs. By adjusting the difficulty, the game changes parameters and adapts the gameplay experience. To create more advanced forms of adaptive behavior, we have to consider more parameters than just the difficulty setting. Frequently, this larger set of parameters aren't set by the user themselves, but are recorded or calculated from the user's performance. This poses a problem because the more input parameters there are, the more complex the rules become to actually change game behavior. One potential solution is to use classifications. A classification is simply a way of summarizing sets of parameter values. Classifications usually have a descriptive name, such as attacking player or stealthy player. Classifications work through mappings. Each possible set of input values is mapped to one and only one classification. The simplified data of the classification is then passed to the game, which is used to adjust adaptive elements instead of the raw parameter data. Let's look at a simple example. Suppose we have three parameters. The first measures if the player is good at hand-to-hand weaponry. The second measures if the player is fast. And the third measures if the player is good with guns. Each parameter is scaled between 0 and 100, with 0 being unskilled and 100 being highly skilled. We want the game to adapt based on the way the user is playing. We use the following classifications to simplify the input parameters. If the player is fast and good with hand-to-hand weaponry, then they are classed as a ninja. If they're fairly slow but good with guns, then they're classed as a terminator. If they're above average at all skills, then they're classed as a soldier. These classifications can be fed into the game to change the behavior of AI, the content of cutscenes, and many other game mechanics. We're now faced with a new problem. How do we determine what classification a set of input parameters should get mapped to? We could use conditional rule systems. For example, if parameter x is greater than 50 and parameter y is less than 20, then map to classification A. Unfortunately, such rule systems often become extremely complicated and difficult for programmers to debug. The solution is machine learning, a branch of computer science used to train programs to understand data. Machine learning algorithms can learn the rules for themselves without us ever having to write them down. All we have to do as designers is show the algorithm examples. Once the algorithm has seen enough examples, it can classify input parameter sets on its own. In conclusion, this leads us to the following design methodology for creating adaptive elements in games. We decide what we want to adapt and the different ways that the element can change, called the outputs. We then design the parameters that will be used as input to produce all the outputs. We then create classifications to summarize different sets of values of these parameters. A machine learning algorithm is then trained to associate the parameter value sets to classifications. And finally, the classifications are associated with different element outputs. Let's see how this process works with Orbit. After the first design step has been completed on paper, we use the Orbit network editor to design input parameters, known as Orbit skills. In the Orbit trainer, we define classifications and train Orbit to understand sets of parameter values. We then build Orbit to a .dll file, which we then use in our game to associate classifications with the element outputs. For the rest of the videos in this tutorial series, we shall be demonstrating this process in Orbit with a turn-based fantasy role-playing game.